lines. We're going to be talking about equations of lines, and then we're going to look at parallel lines and a transversal, which is a line that cuts through. So to start in 3.1 here, we're going to review slope, okay, and slope in terms of parallel and perpendicular lines. So today's lesson should feel like a review of algebra 1 topic. Y'all went real deep with slope in algebra. Y'all talked about slope a lot. Okay, so hopefully a lot of this looks familiar and it makes some light bulbs go off, ring some bells in your memory, okay? So first of all, the steepness of a line is what we are talking about when we talk about the slope. We're talking about how steep the graphed line is, okay? Or if there's not a graph, if we were to graph it, how steep the line would be. Okay, and this right underneath that, we've got 3 lines drawn, and it asks which one has the biggest slope. Well, the biggest slope will be the steepest line. So which of these 3 is the steepest? If these were a hill you were walking up, which one would be the hardest to walk up? The one all the way on the right. That is the steepest. Okay, when I say steep, I mean it's a real fast incline. Okay, the flatter it is, okay, the smaller the slope. Okay, so the steeper it is, the bigger the slope. All right, so when we have a line on a coordinate grid to find the slope, okay, who remembers what you do when you have a graph to find the slope? Okay, so we could plot a couple points on here. So I want to pick points that actually go through the grid intersections, right? I don't want to pick one that's not on an intersection of the grid. Yeah, so find these perfect points. Once you have a couple perfect points, yeah. Okay, go ahead. Once you have a couple of the points, what do I do to get the slope? Jermaine said it. Rise over run. That's what I was looking for. Okay, this little m equals. M is what we use to represent slope. Your slope is your rise over your run. Okay, and when we say rise over run, we're talking about how far do we have to go up or down and then left or right. Okay, so when we are counting our slope on a graph, I would like you to always start on the leftmost point of the 2 points that you picked to measure. Okay, so I picked these 2 points. You may have picked 2 different points. That's okay. The slope should be the same because this is a line. It has a constant slope, a constant rate of change. That's what makes it a linear function. So if I start on the leftmost point, I'm going to have to go up or down to get to the next point. Is that point to the right above or below this one? It's above. I'm going to have to go up. I'm going to have to rise. So when you rise, that means you are going to have a positive slope. Okay, so positive. If you have to go down, it's going to be negative. Okay, and this is if you start on the left point of the 2 points. So I'm going to rise. I'm going to go up 1. And then how far over did I have to go? 2. So when I say my rise over run here, that's rise 1, run 2. So my slope is 1/2. I went up 1 over 2. Okay, as long as you're starting on the left, like I said to you here, your run is always going to be to the right. Does that make sense? Okay, so let's try it in these 3 beneath it. We're just going to pick a couple of points. Morgan referred to them as perfect points. If that's what you want to call them, that's fine. That just means a point that is actually at the intersection of your grid lines. Okay, so at the intersection of my grid lines. So there's one here and here. Okay, so to get from this left point that I picked to the right point, do I go up or down?
Wait, what?
I have to go down, right?
Yeah.
Okay, so that's negative. I went down 3, so that's -3. and then I have to go over 4. So that's all right. You can look at mine. I know I was trying to fit 2 days into 1 page for us because I'm in a meeting tomorrow. And so we're going to do all the notes on slope today and then all the practice tomorrow. But normally we would have done like a little bit of notes, a little bit of practice, a little bit of notes, a little bit of practice. But sorry, when I copied it over to try to get it to 1 day, it's kind of small. So if you can't see, if the grid lines on these smaller graphs didn't copy real clear for you, just look up here at mine. So I've got down 3, right 4. So my rise over run would be -3 over 4. That's my slope.
Easy so far.
Good. All right, so then I'm going to pick some points here. The the y-intercept is a perfect point. And up here's a perfect point. So I'm going up, I'm rising 4, and then over 1. So rise 4, run 1. Now I can reduce that. What's 4 divided by 1?
4.
4. So if it's a number that you can go ahead and divide or you can reduce, you do that. Okay, dividing by 1 doesn't do anything. It's just 4. Okay, so on the third one here, let's see, we've got, there's a perfect point and here's a perfect point. So that it would be a rise 2 and a run 3. So my slope would be 2 over 3. Do we feel okay about counting slope? Yeah. Okay. Now, before I jump into the formula for when you don't have a graph, on the right side here, I want to look. It says there are 4 types of slope. Who thinks, looking at these 4 graphs on the right side, if they know some of these types?
Positive?
Okay, that's correct. That first one is positive.
0?
We know that it's positive. Hold on, let's talk about, okay, let's talk about positive real fast.
Slope dude.
All right. So positive means that it is going up when we read it from left to right. So reading it from left to right is the key part there. Okay, from left to right. If it is increasing, going up, then that's how we know it's positive.
We ever watched Slope?
I've never heard of that.
You've never heard of Slope? No, miss, if you actually, have you heard of Slope dude? Miss, if you pull up the video right now, we'll know.
Okay, well, let's finish our notes if we have time, though. All right. So left to right, if I trace this with my finger or my mouse, okay, if I go left to right, I'm going up. I'm increasing. So this is a positive slope. Okay, and then the reverse of that is this third one here. If I go left to right, I'm going down. Okay, that is decreasing. Which means we have a negative slope. So I think most of you are good with positive and negative. It's going to be these other 2 that y'all tend to mix up. That's going to be the more common. So if it didn't print much darker, maybe accentuate it, trace it, make it darker. This is what we're looking at on the graph right here. Okay, if we have this is a horizontal line, right? So I'm going to write horizontal. If you have a horizontal line, okay, the slope is 0. And the reason is, think about us counting our rise over run, if this helps you. So my rise over run, if I picked any 2 points on here, it doesn't matter which 2 I would have picked because the rise would be 0, right? To get from this point to this point, I don't go up any, do I? I just go over. So I've got 0 rise, and then whatever run, it depends on how far apart I put those. In this case, I put 5, but I could have put them 1 apart, 2 apart, 3 apart, 10 apart. What's 0 divided by any number?
0.
0. So when you count your rise over run, you get 0. So a horizontal line has a 0 slope. Okay, now alternately, what happens when you have a vertical line?
Undefined.
Okay, and the reason is, if you didn't hear him, he said that is a undefined slope. Okay, you may also hear that called no slope. 0 slope and no slope are not the same thing. So undefined or no slope is different. This is when you have a vertical line. And again, I'm going to show you the reason why. If I pick 2 points to measure between, okay, it doesn't matter which 2 points. If I go to list my rise over run, because it's a vertical line, the rise could be anything. I could have put these points 1 apart, 2 apart. Here, I put them 5 apart vertically, but the run is 0. I don't have to go right or left any, do I? Okay, so here is why it's undefined, because 0 is in the denominator. 0 is the run, and you cannot divide by 0. If you try to divide by 0 in your calculator, you're going to get an error. It's not going to do it. It's undefined. Okay, think about 0 in the numerator versus denominator. Let's think about dividing. Let's say I have 0 cookies, and I'm dividing it up between 5 people. How many cookies will everybody get?
0.
0, because there were 0 to begin with. But let's say there's 5 cookies and there's no people to split them up between. Okay, I can't, that's impossible. I don't have anywhere for the cookies to go. This doesn't make sense, does it? Okay, so if that helps you to kind of visualize it better, just understand you can have 0 of something and you split it into this many groups, there's 0 per group. But if there are no groups to split up your items into, it's impossible. Okay, that's undefined. Questions so far? All right, now, if we don't have a graph, okay, we want to find slope, but we're given ordered pairs, we have to use slope formula. So remember, slope formula is the change in y over the change in x. Okay, so the change in y over the change in x. So your y's over your x's. So when we say the change, okay, think graphically, the change in y is this vertical distance. It's how far apart are the y values of your points. And then the change in x is the horizontal, the run. How far apart are the x values of your point? Okay, so the change is the difference. Difference means to subtract. So your formula is y2 minus y1 over x2 minus x1. Okay, now there is a symbol in math, a Greek letter that's used to represent change. You may or may not have heard of it. It doesn't matter if you have or not. I'm going to tell you right now. This triangle, does anybody know what Greek letter that is? Anybody know their Greek alphabet?
A.
No. Alpha is A.
Triangle.
It looks like a triangle, but that's called delta. Okay, if you've ever seen any TV shows or movies, or you've had someone in your family in a sorority or a fraternity or something, you know how they have like Kappa, Delta, Pi, like those Greek letters.
Like how to get like.
Yeah. So delta is a Greek letter. Okay, so it looks like a triangle. That's called a delta, and in math, the delta symbol means change. So you may, So you may see it written as delta y over delta x. That means change in y over change in x. So that's like a shortened way, kind of an abbreviation to write that out,
So
to write your slope.
So can we do like this delta sign?
Yeah. So let's try it. So I want to find the slope of the line that goes through these 2 points. So I want to find the change in y over the change in x. So I have to identify my x's and my y's. So my x's, okay, remember, my x's, if you don't have 2 colors to color code with me, why don't you use a circle for your x's and then do like a box for your y. If you have 2 colors, I would color code, but if you don't, that's okay. Use circles and squares or something like that. Okay, so I want the change in my y's, so I'm going to subtract my y's. It doesn't matter what order. You get to pick, is this 0.1 or is this 0.1? You set it. It doesn't matter. You're given 2 points. You decide. Now, you have to be consistent. Just like when we did distance formula back in Unit 1, and we had to subtract the y's and the x's. I said, okay, for the y's, if I do 3 first and then the 1, when I go to plug in my x's, which x do I have to do first? Yeah, if I did for the y's, I put the 3 first. So when I list the x's, which x do I have to list first?
So what's the 2?
The 2, that's it. I have to be consistent in the order. So when I plug them in, it doesn't matter for the first set, I get to pick, but then I have to be consistent and make sure the other one's in the same order. So I went from 0.2 to 0.1, from 0.2 to 0.1. Now notice, there is a minus in the equation, and then there is a -4. Do not forget to keep your sign. Don't think, oh, there's a negative, that's a minus already. Yes, that's from the equation. The negative with the 4 is different, so you need both. So what happens when you have minus a negative?
8.
Yeah, that becomes addition. So in the top, 3 minus 1 is 2. And in the bottom, 2 plus 4 is 6. So my rise over run, my slope is 2 over 6. But if you can reduce, we want to reduce. Who remembers how to reduce fractions? It's in this case, you're dividing by 2. It's not always dividing by 2, but you're looking for a common factor in the top and the bottom, the numerator and denominator. So what is a common factor of both 2 and 6? And in this case, it's a 2. Both of these can divide by 2 evenly. So if I do 2 divided by 2, I get a 1. And if I do 6 divided by 2, I get a 3. So 1/3 is my slope. We follow? Now, you could use Desmos and plot these points and get a picture. If you like doing the picture so much better, you're like, oh, counting rise over run, that's so much easier. Okay, plot these points in Desmos and give yourself a picture. It'll plot the 2 points for you, and then you can just count. Or get a piece of scratch graph paper back here, or the whiteboards that have the grid on them. Okay, you're welcome to do it that way if that's easier for you. Okay, but this is the formula. This is the algebraic way. Now, I'm going to just review some of these fractions that we need to be able to reduce. Okay, because sometimes you get a weird fraction. You're like, oh, what do I do? Okay, so y'all reduce 2/6 to 1/3. Let's try a few more. What would -3 divided by 9 become? Nope. If it was 9 divided by, if that was flipped upside down, yes. But yeah, if the number is smaller on top than on bottom, you're not going to get an integer. It's going to have to stay a fraction. Okay. So when I talked up here, I said, what could 2 and 6 both be divided by? And it was 2. What can 3 and 9 both be divided by? 3. So if I divide both of those by 3, first of all, I immediately know it's negative because I have a negative divided by a positive. If you have opposite signs, gentlemen, I need the side conversations to come to an end. Thank you. Okay, if I have a positive and a negative my answer is going to be negative. If they're the same sign, like here, they're both positive, my answer is going to be positive. If they're both negative, my answer is going to be positive. And it's the same with multiplication. Okay, so if they're the same sign, it comes out positive. If they're opposite signs, it comes out negative. Okay, but y'all told me to reduce. Both of these are divisible by 3. So Josh, what's 3 divided by 3?
0.
Nope. 1. Good. All right, guys, cut it out. All right, what is 9 divided by 3? Okay, so then the bottom is a 3. So that ends up being negative 1/3. Okay, so that reduced to negative 1/3. Okay, what about 4/10? Okay, Alan, what can be divided out of both 4 and 10? 2. So your name's not Alan.
It could.
Okay, so if I divide out a 2 from both of these, okay, 4 divided by 2 is 2. 10 divided by 2 is 5. So 4/10 reduces to 2/5. Yes. All right, here, when we said a second ago, if our denominator is 1, if we're dividing by 1, does dividing by 1 do anything? No, it doesn't change anything. Okay, so that is simply 4, right? Okay, what if I have a negative number divided by 1? It's still the same. It's just negative 7. It doesn't matter if it's a positive or a negative. If we're dividing by 1, nothing is changing. It's just whatever's in the numerator. Okay, now here we have a negative divided by a negative, so that's going to come out positive.
Positive 1/5.
This is 2/3. So 2 and 3 don't have a common factor, do they? So I can't reduce this. So it's just positive 2/3. Okay. All right. Negative divided by negative. This is negative 1 over negative 8. The negatives cancel. Okay. It becomes positive. But 1 over 8, that doesn't reduce. It stays 1 over 8. But it's positive. I like that. I would like to hear that you think it's easy. Okay, what's a positive divided by a negative? And this one's going to be negative. Do 4 and 7 have a common factor? Nope. So it stays negative 4/7. So here, nothing really changed, except instead of having the negative written in the denominator, you can write the negative out front of the fraction. Okay, that means the same thing. Okay, so same thing here. I've got 1 over negative 8. Okay, I can't reduce, but I can bring that negative out in front of the fraction instead of leaving it in the denominator. All right, okay, now this is getting trickier. What's that 0 do?
0. It's just 0.
Yeah, it's just 0. If you gentlemen, shh.
I'm sorry.
They're back here. If you have 0 divided by any number, it doesn't matter if it's a positive or a negative. 0 divided by a number is going to be 0. So those are both a 0 slope. I don't know what's happening. I think I accidentally clicked that. Hang on. Now, what about when 0 is in the denominator? What did we say? No, 0 divided by a number is 0, but a number divided by 0 is.
Just 12.
What'd y'all say over there?
The number?
No, let's look back on up here. What did we say for vertical line versus horizontal line? When 0 was the rise, we got 0 for the slope. But when 0's the run, what was the slope? Undefined. You cannot divide. If you try to divide this in your calculator, you're going to get an error. You can't divide by 0. You can't split something into 0 groups. Okay? So that is undefined for those two. All right, y'all give these 3 a shot. I'm going to get our attendance in. I want everybody trying at least one of these. Pick one of these to try. If you finish, try another one. Okay, and then we're going to come back and check them. Okay, but I'm going to put in attendance while everybody is trying those. You can talk to each other at your table. Okay, but you're identifying your X's and your Y's. This is like the one we just did right here with the pink and purple, or the blue and purple. Okay, so you're doing the same thing we did here.
You say 6, 7.
Guys, cut it out. All right, those of you with your heads down, get your heads up.
Oh, yeah. What?
Deja, Jermaine, Jalen, Alan, go get your heads up. You should be trying these. All right, let's check it out. Let's see what y'all did. Okay, if you got one of them, that's fine. If you got a couple, that's fine. If you didn't get all the way through, it's okay. Let's follow along. Remember, we're doing the change in Y over the change in X. So I'm going to set all of them up. All right, now I'm going to identify. I did my Y's in green. So these are my Y's. And I think, actually, I know I didn't do green. I did blue. Okay, and I used squares. Okay, so I'm going to keep that consistent. So these are my Y values. What order, somebody who tried this one, what order did you put your Y's? You put the 2 first? Okay, so 2 and then -1. That's fine. So now when I identify my X's, I have to go in that same order. So which X would have to go first? The 6 would have to go first because the 2 went first on top. The 6 goes first on bottom. So then the 4. So then I've got minus a negative here. So I'm adding. So that's 3 over 2. If you switched the order, as long as you switched both on top and on bottom, it's okay. You still should have at the end come out with positive 3/2. Positive 3 over 2. Okay, if you tried this next one, see our Y's are -2. I'm going to go in this order. And then 3. My X's are 3 and 4. So if I did it this way, I'd have -2 minus 3 is -5. And 3 minus 4 is -1. What's -5 divided by -1? Positive. A negative divided by negative, so positive, and that's a 5. If you switched it around, if you did the 3 minus -2 and then 4 minus 3, you still should have gotten positive 5. Okay, so let's say you did -3 and 0 for your X's. You would have had to do 12 and 4 for Y's. So that would give you 8 over -3. And you can write that negative out in front. So -8/3. You what? Okay. Questions about finding slope either with the formula or by counting rise over run on a grid?
No, the way you teach is really easy.
Good, I'm glad. All right, let's flip it over then. Now we're going to start talking about what parallel and perpendicular mean in terms of slope. Okay, you did learn this in Algebra 2, or not Algebra 2, you haven't taken that yet. Algebra 1. So in Algebra 1, once y'all had learned about slope, you did talk about parallel and perpendicular lines. Okay, and we've talked about parallel and perpendicular lines already this year, but we haven't talked about it in terms of slope. So we're going to talk about it in terms of slope. Remember, these are the symbols. This symbol for parallel looks like parallel lines. Okay, parallel means that they will never Okay, two lines that never cross, they never intersect, but they're on the same plane. Why don't they intersect? Who knows why parallel lines don't intersect? So if I were to look at one of these lines that I had graphed, if I graphed a parallel line, it would have to do what? It'd have to have the same slope. It'd have to have the same slope. Okay, to be parallel, you have to have the slopes of the lines are the same. That's why they never cross. Okay, so same slope. Parallel means same slope. Okay, perpendicular. This is the symbol for perpendicular here. Okay, perpendicular lines intersect, but not just at any intersection, a specific intersection. What does perpendicular mean? What type of angle do perpendicular lines make?
They cross.
They cross, but at a specific angle size.
Yeah.
What's the angle?
Right.
Yes, a right angle. Okay, at a right, which is how many degrees?
I think it's like 90.
It's exactly 90. It's not like 90. Okay, they intersect at a right angle. Okay, that's why the symbol looks like that. They're making a right angle. So
that's not.
These are perpendicular lines. They intersect at a right angle. Okay, now the slopes. The slopes of perpendicular lines are not going to be the same. They're the same. That's parallel. So obviously they can't be the same. Okay, so the slopes, does anybody remember from Algebra 1 how do perpendicular line slopes compare?
Oh,
it's okay if you don't remember. Does anybody?
perpendicular.
Okay, they are opposite.
Opposite.
No, not opposite angles. I'm talking about the slopes. The slopes are going to be opposite reciprocals.
I knew that.
Okay. So opposite reciprocals. So perpendicular slopes are opposite reciprocals. Now, if you don't know what opposite reciprocals are, that doesn't help you very much, does it? Okay, so an opposite reciprocal, opposite means to change the sign. So the positive or negative. Okay, and then reciprocal means you flip the fraction. So your numerator and denominator switch. You flip the fraction upside down. Okay, so we're going to look at that here. We want to list some opposite reciprocals, or sometimes they're called negative reciprocals. That means the same thing. Okay, so I'm given a slope and I want to have the opposite reciprocal. So the first slope is 3/4. What's the opposite of positive?
Negative.
Okay, so I know it's got to be negative. And what's the reciprocal of 3/4? 4/3. So change the sign, flip the fraction. Okay, now 2 is an integer, meaning it's not a fraction. So yes, how could I write 2 as a fraction so I can flip it? What would be the denominator? What would be 2 divided by what would still be 2? 1. If I put a number other than 1 under there, it's no longer a 2, is it?
No.
If I put a 2 underneath, 2 divided by 2 is 1. That's not a 2. To keep it to where I'm not changing the value, it's still 2, but I see it as a fraction. So anytime you have an integer, okay, that means a number that's not a fraction, okay, you can put it over 1 to make it a fraction. So now what's going to be the opposite reciprocal of that? Okay, but opposite is negative. Negative 1/2. Okay, now this number 3 starts negative, so the opposite is going to be positive. And then instead of 7/8, it'll be 8/7.
Oh, like 7, 8, 6, 7.
Now 1's a little tricky. If I do the same thing I did with the 2 and I put a fraction here to help me, what's 1/1 flipped?
Wait, what was going?
Number 4 has a 1. If I make it a fraction, just like I did with the 2, and I put it over 1, what is 1/1 flipped?
1/1.
It's still 1/1. So for 1, the number doesn't change, but what's the opposite? It's still negative. So 1 and -1 are perpendicular slopes. Those are opposite reciprocals. 1 is the, no, it's not. It's another kind of tricky one. Let's look at what we said on the front. If we have a 0 slope is a horizontal line, right? What type of line would make a 90-degree angle with a horizontal line?
Undefined.
So, guys, I need these side conversations to stop because y'all don't know this. I'm trying to teach it to you, and half of you aren't listening. Stop talking and listen. If I have a horizontal line, that's a 0 slope. If I want to make a 90-degree angle, don't I need a vertical line?
Yeah.
And we said that a vertical line has what type of slope?
Undefined.
Undefined. And that's because if I were to flip this fraction 0 over any number, okay, let's do a 1 like we did for the others. If I were to put 0 over 1, if I flip that 1/0, that's undefined. You cannot have 0 in the denominator. So the opposite reciprocal to 0 is undefined. And I ran out of room there. I got to write smaller. Because that would be 1/0, which we can't do. Do we understand that? All right, let's try and apply this. If I am given the slope of line AB is -5/4, I have to be able to give the slope of a line parallel to that and the slope of a line perpendicular to that. So we said perpendicular is opposite reciprocal and parallel is the same. So if the slope is -5/4, what is the parallel slope? What did we say up here? Parallel lines have the same slope. So it doesn't change. It's -5/4. It's that easy. Don't overthink it. Parallel means same slope. This symbol I did, that's the symbol for parallel. So if the slope is -5/4, the parallel slope is -5/4. Okay, the symbol for perpendicular is this. So the perpendicular slope would be what? I need the opposite sign and the flipped fraction. What would it be? Yeah, it'd be +4/5. Because you do the opposite sign and flip the fraction. Opposite sign, flip the fraction. Okay, so if you're straight up given the slope, it's that easy, guys. Now this next one, I'm not given the slope. I have to count it. Okay, I have the graph, so I need to count my rise over my run. Yep. So rise 7, run 3. So that's the given slope. And then it says to find the slope of a line that is perpendicular. So what do I do? If the slope is 7/3, what will the perpendicular slope be?
3/7.
What 3 over?
-3/7.
-3/7. Opposite sign, flip the fraction. All right, last but not least, we have 2 lines. They're giving us the coordinates, and they want to know, are these lines parallel, perpendicular, or neither? Lines don't have to be parallel or perpendicular. They could intersect at not a 90-degree angle, right? So that's what we have to determine. So we're going to take my slope formula, my change in y over my change in x, So what did I do? I did purple was F. Okay. So my X's for line AB and my Y's for line AB. So this slope would be 2 over -3. So that's -2/3 for the slope of line AB. Then I need to do the same thing for CD. So my Y's are 2 and 3.
It's really even 2 minutes.
My X's are -1 and 3. So that would be -1 over -4. What's a negative divided by a negative?
Positive.
So +1 over 4. Are those the exact same slopes? Anybody? No. So they're not parallel. Are they opposite signs?
Yeah.
They are. One's positive, one's negative, but are they flipped fractions? No. So they're not perpendicular. So these are not parallel or perpendicular. They're neither. Keep those notes. There's no homework. You're going to practice this tomorrow. Bring those notes and a laptop and charger with you tomorrow to practice. No homework. If you have missing work, try to play catch up.